Bismillahirrahmanirrahim. How are you, students? Today we will study physics, subject physics, class 10th, lecture number 6. Today we will do numericals. The first numerical is 10.1 on page 17. On page 17. Today the first numerical is the time period of a simple pendulum is 2 seconds. 10.1 data. The time period of a simple pendulum is 2 seconds. What will be its length on the Earth's surface? What will be its length on Earth's surface? Length on Earth's surface. And what will be its length on Moon? You have to calculate length on Earth's surface and length on Moon surface. The value of G on Earth's surface is given 10 meter per second square. And the value of G on Moon surface is G by 6 is equal to 1.63 meter per second square. So this is the data. The formula for the time period of a simple pendulum is T is equal to 2 pi under root L by G. T square is equal to 4 pi square L by G. So L is equal to G T square divided by 4 pi square. Use this equation for Moon and for Earth. You can calculate the value of G. You can calculate the value of length. So you will write for Moon Lm is equal to Gt square divided by 4 pi square. And for Earth you will write Le, and here you will write E. Now put the values and calculate the answer. Now I will now 10.2 data. 10.2 numerical is a simple pendulum of length 0.99 meter. 0.99 meter. So length is equal to 0.99 meter. Is taken to the moon by an astronaut. The period of the pendulum is 4.9 seconds. Time period is 4.9 seconds. Time period is 4.9 seconds. What is the value of G on the surface of the moon? Now T is equal to 2 pi under root L by G. Squaring, we will get T square is equal to 4 pi square L by G. L by G. So the value of G will become as 4 pi square L divided by T square. Put the values, you will get the value of G. Now 10.3. Find the time period of a simple pendulum of 1 meter length. 10.3. The time period of a simple pendulum is find the time period of a simple pendulum of 1 meter length. So time period, we have to calculate time period on Earth and Moon surface. So T per Earth and Tm per Moon. m per moon. Placed on Earth and Moon, the value of G on the surface of the Moon is 1/6. 1/6 the value of G on Earth. It is already calculated. So take the value of Gm 1.63 and the value of G on Earth surface is 10 meter per second square. Calculate the time period. So just putting the simple relation. Length is 1 meter. Length is 1 meter. T is equal to time period on Earth surface is equal to 2 pi under root L by G. LE and GE. Length remains same for both the object. And time period on Moon surface is equal to 2 pi under root L divided by GM. Put the values, you will get the you will get the time period. 10.4. The simple pendulum completes one vibration in 2 seconds. Number of vibration, the time required to complete one vibration is called time period. Data. Time period is 2 seconds. Time period is 2 seconds. Pendulum completes one vibration in 2 seconds. Calculate its length and G is 10 meter per second square. Calculate its length. So T is equal to 2 pi under root L by G. T square is equal to 4 pi square L divided by G. So L is equal to G T square divided by 4 pi square. You can calculate the value of length by using this equation. Put the values. 10.4 is done. 10.5. If 100 waves passes through a point of medium in 20 seconds. 10.5. Number of waves passes is 100. And the time per 100 waves is 20 seconds. Determine its frequency. Determine its frequency, time period, and velocity. When wavelength is 6 centimeter, 0.06 meter. Frequency is equal to N divided by T is equal to 100 divided by 20. So frequency is equal to 5 hertz. Time period is equal to 1 by F is equal to 1 by 5. You will get 0.2 second. And V is equal to F lambda. F is equal to 5 and lambda is equal to 0.06. You will get the answer. Now, check the answers. Now, 10.6 is a wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 hertz. 10.6. Frequency is 12 hertz. Frequency is 12 hertz. The resulting wave has a wavelength of 3 centimeter. Wavelength is 3 centimeter is equal to 0.03 meter. Calculate the wave velocity. What is the speed of the wave? So V is equal to F lambda. Put the values, you will get the answer. 10.7. A transverse wave produced by on a spring has a frequency of 190 hertz. So frequency is 190 hertz. 10.7. Traveling along the length of the spring of 90 meter. The length is 90 meter. Travels along the length of the spring 90 meter. It's not wavelength, it's length. So length is 90 meter in 0.5 second. Time is 0.5 second. What is the period of the wave? So time period is equal to 1 by F. 1 by 190. 1 divided by 190. You will get the time period equal to 0.05 second, which is equal to 0.01 second. Do the calculation. The next is what is the velocity? So we have the time period, but we don't have the wavelength. So we cannot calculate it from V is equal to F lambda. We will do it S is equal to according to VT. So V is equal to S divided by T. S is 90 divided by its 90 divided by time, which is 0.5 is equal to 180 meter per second. And the next is wavelength. So per wavelength, per lambda, we will calculate V is equal to F lambda. Lambda is equal to V divided by F. We have the velocity. This is the velocity. And we have the frequency, so you can calculate. Now next numerical. 10.8. Water waves in a shallow part are in a shallow dish are 6 centimeter long. 6 centimeter long. At one point, the water waves moves up and down at a rate of 4.8 oscillation per second. What is the speed of the water surface of the water waves? What is the period of the water waves? So first we will calculate, we will write data. 10.8 data. Wavelength is 6 centimeter is equal to 0.06 meter. So we will write the wavelength and frequency is 4.8 hertz. Oscillation per second 4.8 hertz. We have to calculate velocity and time period. Time period. So velocity can be calculated by V is equal to F lambda. Wavelength is given, frequency is given, so you can calculate. And time period is equal to 1 by F. So you can calculate by putting the value of frequency 4.8. You can calculate the frequency. Now numerical 10.9. 10.9. At one end, a parallel tank 80 centimeter across. 80 centimeter across. At one end, a parallel tank 80 centimeter across. A 500 hertz vibrator produces waves whose wavelength is 40 millimeter. Find the time. Find the time the waves need to cross the tank. We have to calculate total time. So first we will write data. Frequency is 5 hertz, 10.9. Frequency is 5 hertz and wavelength is 40 meter. What we have to calculate? We have to calculate the time to cross a distance of 80 meter, to cross a distance of 80 centimeter, to cross a distance of. So first we will write V is equal to F lambda. V is equal to F lambda. We will calculate velocity by putting the value of frequency and wavelength. Wavelength is this one, frequency is this one. So put the values, you will calculate velocity. And then V is equal to S is equal to Vt. S is equal to Vt. So T is equal to S divided by T. Distance is 80 centimeter. So you will put the value 80 centimeter and divide by S is equal to Vt. T is equal to S divided by this is V. So you will put the value of V. You get from this equation. Put that value in this equation, you will get the time. Now, next numerical is what is the wavelength of the radio waves transmitted by an FM station at 90 megahertz? Frequency is 10.10. What is the wavelength of radio transmitter? 90 megahertz. 90 megahertz. You will write 90 cross 10 raised to power 6 hertz. Wave speed of radio waves, wave velocity is 3 cross 10 raised to power 8 meter per second. What is the wavelength? So V is equal to F lambda. Lambda is equal to V divided by F. V is 3 cross 10 raised to power 8 meter per second and frequency is 90 cross 10 raised to power 6. You will get the wavelength. These are the numericals that we have completed. So in next lecture, we will do the MCQs, short answers, and the conceptual questions. Thank you, students. Allah Hafiz.